This is the first of two videos discussing the cabin heating system of a Boxer Ducato Jumper style fan, and handles most of the problems you can run into. I've created this fault finding flowchart as a guide. It is divided in a branch for mechanical related problems on the left and electrical related problems on the right. This allows you to jump to the relevant part of your problems if you don't want to watch everything. Which side you fall in depends on this first observation. If your fan is working fine, but it keeps blowing cold air even after you've been driving for a while, then there is some sort of mechanical issue, so this video will have you covered. If it is the fan that is not working, check out part 2, though you are of course invited to watch this one as well to get the full picture. I will begin by taking a look at how heat is managed in a car. Let's start right at the source, the engine. As the engine runs, it generates a lot of heat. So we have a liquid coolant flowing through the engine block to soak up that waste energy. The heart of this coolant system is the water pump. It's constantly spinning to push that hot fluid out of the engine and towards the radiator at the front of the car. Normally the air is pushed through the radiator because we are driving. But if that's not enough, because for example we are in a traffic jam, there are also big fans mounted on that radiator to provide additional airflow. However, the coolant doesn't always go straight to the radiator. We have a thermostat that acts like a gatekeeper. It stays closed when the engine is still cold to help it warm up quickly, and it only opens once the engine reaches its ideal operating temperature. But even when closed, a bit of coolant can flow to prevent creating hot spots in the engine, and also to allow the thermostat to sense the engine temperature. To keep the pressure stable, we have a coolant reservoir. This tank acts as a space for the fluid as it expands and contracts with the heat. This is also the place where we can check the fluid level and add more when needed. Now we also use that waste engine heat for our own comfort through a secondary coolant loop. Some of that hot coolant is diverted away from the engine and sent into the dashboard to a device called the heater core. You can think of this as a miniature radiator designed specifically for the passengers. Since normally we don't have a lot of air movement inside the cabin area, we need a blower fan that pushes air through that hot heater core. To manage the temperature, we have a few control mechanisms. The first is just a physical flap. When you turn the temperature dial, you're actually moving this flap with a cable to decide how much of the air moved by the fan hits the heater core versus how much stays cool. The second control mechanism is the electrical side, to control the fan speed, but I will handle that in the next part. First, let's go through some possible mechanical problems using the fault finding flowchart. A first easy thing to check is the coolant level. Pop the hood and take a look at the level in the reservoir. If it is too low or even empty, check for leaks and top it up to the indicated max level. Some examples of leaks are a cracked radiator, a broken sealant ring in the purge valve, damaged hoses, but there can also be internal leaks like in the heat exchanger that cools down the exhaust gases before entering the EGR valve, and these are much harder to spot. So it's best to keep track of the level if you had to refill it and there was no obvious cause. After topping up, you might need to purge trapped air, which brings us to the next check. There might be air trapped in your heater core, preventing a good flow. You can purge that air via this valve. Turn it counterclockwise till air starts escaping and stop when it becomes fluid. Pay attention to not over-tighten the valve. There is a rubber sealing ring inside, and when it breaks, it causes your coolant to slowly leak away. Another problem could be that the thermostat is stuck in open position. In that case, especially when it's cold outside, it will take a really long time for the engine to reach its operating temperature, and therefore also a really long time for the cabin heater to blow hot air. One way to check this is to monitor the pipe going to the radiator while the engine is heating up. The thermostat is located there, at the end of this collector, and this is the pipe going towards the radiator. Under normal circumstances, the pipe is partially blocked from view, but there are still plenty of access points. When your thermostat is working correctly, this pipe should remain cold in the beginning, till the thermostat reaches about 85 degrees Celsius. Then it opens, hot coolant starts flowing toward the radiator, and it rises abruptly in temperature. But when a thermostat is stuck open, the pipe's temperature will slowly rise together with the engine temperature. And finally, when it's stuck closed, your engine will overheat while the radiator remains cold. You can use, for example, a laser thermometer to make the temperature measurements. Maybe do a quick trip around the block between checks if idling is not leading to results fast enough. Another problem could be that your cabin radiator heater core is blocked. I never had that particular problem, but I've seen some reports of people for whom it was the case. You can disconnect the tubes going to the core here and try flushing it till it clears. I am a bit afraid though about what that means for blocked passages in the engine or engine bay radiator. And as a last item on the mechanical side, it could be that there is a problem with the valves regulating the airflow, like a broken cable. I suspect you can feel that when turning the rotary dial to select the temperature. If you are lucky, something broke on the control panel side, which is still relatively easy to access, as I will show later when talking about the switch selector. But if you need access to the valve itself, it is a lot more work as it involves taking off the dash. It is not that hard, I managed to do it once on a remote beach in Greece during a road trip, but it involves a lot of screws. So that concludes this first part. I hope it managed to shed some light on the issues you might be having. For electrical issues, continue to part 2.